Hi, first I want to show the principle of the decryption and the encryption. And okay, let's start with this because I did it with an Excel file to be sure that all my formulas and guesses and thoughts are correct. Here are some constants. A minute has 60 seconds, an hour has 60 minutes, and what is important is the only figures you are allowed to change are the green figures on a yellow background. So these are this ones, and this ones. Okay, I would like to go on with the explanation. We have two different ways from station 1 to station 2, a short one and a long one. For the short one you have minimum time to go to from station 1 to station 2 of 7 minutes. The maximum time is 15 minutes. And if you are choosing the long run, you have at least 15 minutes and a maximum of 90 minutes. Just to show the most complicated situation you can face is shown here because the actual time is 23 hours, 5 minutes and 10 seconds, which means that there's a probability that the target is on the next day, so this means after midnight. Okay, but I will show this later. So it is 23 hours, means 11 p.m., 5 minutes and 10 seconds, and the long way was chosen. Here this figures is now calculated as seconds. So as you can see here, it's 10 multiplied with 1, which is not so important because 10 multiplied with 1 is still 10. Then here you have the 5 multiplied with the 1 and the 60, which means multiplied by 60. And at the end you have the 23 multiplied with 60 and with 60 and with 1, which is giving you a figure of 38,110. If you're choosing the long way, there's an increment of 200,000. So this means that the actual value is 283 and 110. 283,110. You can see this figure here again. This seems to be very equal, but this is a figure while this is text. This means this is the first figure, the second, the third, the fourth, and so on. And here now the figure is separated to digits. So the first one, the 2 is here, the 8 is here, the 3 is here, and so on. And this is the encryption key. So this means, what does it mean? On the fourth figure here will become the first one. The third figure here will become the second one. The sixth figure here will become the third one, and so on. Doing so, and now the figures calculated back to a string. So the timestamp in this case is 130, 128. So this is a timestamp which will be given at station 1. It will say two things. The one thing is the actual time at station 1 and that the long way was chosen. I will show you shortly if I'm using the short way. If it would be the short way, the figure of the time is still the same. Here is now the figure in plus the increment as a string, and here is a time code. Quite equal to the first one, but quite different because it's only the 2 became the 1. I will go back and you can see it again. So, at station 1, the cacher is getting the timestamp. At station 2, he has to key in the timestamp. Now the timestamp is converted back. This is a backwards conversion. So this means the first figure will be the fifth one. So you can see here, the fifth one is a 2. The second one will be the eighth one, the 8, and so on. So this means at the end, this is a timestamp which is encrypted. And as you can see, it's pretty the same as here above. Now, the timestamp, the maximum, I can see it in this cache, a little bit more or less than 90,000 is the maximum time. So this means 23 hours, 59 minutes, 59 seconds is something a little bit less than 90,000. So if the figure is greater than 200,000, this means that the increment was 200,000, the long way was chosen, and when I'm subtracting the 200,000 from the 283,000, the result is 83,110, and you can see it's the same like here. And now this is converted back. Some steps I will not show you, but this at the end is the result. It's the timestamp is recalculated to 23 hours, 5 minutes and 10 seconds, which is exactly what was given at station 1. And the additional information was that it's a long way. Because it's a long way, now here, you can see it here in the formula. Unfortunately, German. When means in German the same as if. So because it was a long way, the maximum time is 90 minutes, the minimum time is 50. So now let's calculate the maximum time. The maximum time is 5 minutes plus 90 minutes means 95 minutes. Okay, 95 minutes is a little bit too much. So this means here 60 minutes are subtracted and the figure goes from 23 plus 1 is 24, but because 24 is not existing, it becomes 0. So this means the maximum time you have is hour and 0, 35, 10. This means 35 minutes and 10 seconds past midnight. The minimum time is calculated the same way, and this is 23 hours, 55 minutes and 10 seconds. Both are calculated again as seconds in total. So this means 10 plus 35 multiplied with 60. Here now is a very special situation. I said it at the beginning, because the time frame is over midnight. So you can see what is not usual. The maximum time gives a smaller time than the minimum time. Minimum time is still prior midnight, while maximum time is after midnight. In that case, you can see now that the valid time slots are between midnight and after midnight. These are the 35 minutes. Or this figure means this 23 hours, 55 minutes and 10 seconds up to midnight. As I said in the beginning, all in seconds is 86,399. So in this case, it means that the cashier has to arrive between 23 hours, 55, 10 the one day, or 35 minutes, 10 minutes past midnight the next day. Again, to show it with the short way. In the short way, it's more or less the usual thing. Again, 15 minutes maximum, 7 minutes maximum. This is the time, so you can see that the cashier has to arrive 23, 5, 10. Again is the actual time. So 7 minutes later, it's 12 minutes. and 15 minutes later it's 23:20 minutes. And in this case you can see that maximum value is larger than the minimum value, and at this time this calculation will be done if the cacher is arriving between these two timestamps. Okay, was not my explanation so fluently, but I hope you will understand. This Excel file will be a part of the files I will put into Dropbox and also inside the zip folder in the internet, so that everyone. Now some few words regarding the sketch. As you can see, the sketch is separated in a lot of tabs. So this is the main program. Here is one part only to show the time and the date and so on the LCD screen. Here is my usual subroutine for writing text to the LCD. Something is new here. It's this part, because here, as you can see, LCD write was already existing since long. Now here's a new function, which is, or subroutine, which is called LCD center, which is at the end calling the LCD write. So what is new? It's trimming all the 4 lines and then centering it. So that means you can write text left orientated, and automatically by using this LCD center subroutine, it will be centered on the LCD screen. This is a part for reading the time from the RTC clock. Here a small conversion from binary to decimal, and here is already something which you will not see on the screen, because it said that the RTC is ready here, and then it's checking the year. If the year is smaller than 2016, it's saying that the RTC is not ready. So, and if the RTC is not ready, it will say to you, sorry, that the battery must be replaced, blah, 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 and that you should send an SMS or call the owner. The owner number is given in the main program. Or if everything is fine, it's only showing the times. This means the date and the time and the weekday, what I have all learned when I'm trying to program the RTC. So this is already a part of the sketch. This is my very famous, I think only 5 lines long subroutine wait a while, which is used instead of delay, because delay is really stopping the Arduino totally, which means that even the internal clock is not going on. So this is why I'm avoiding, since many sketches, to use a delay command. I'm using wait a while, where only inside the counter is running, nothing more, and it's checking if the time of the delay is reached. So I call it delay, but in reality it's not a relay, and which is quite usual here. Here are all the welcome screens and so on. Okay, here is how the RTCs are connected to the Mega. The LCD screen in station 1, how the button pin is connected. There must be one button for changing the way and so on. And on station 2 there is a keypad you will see, and this is how this is connected. As you can see, a lot of libraries are included. Here is the main thing. Again, here you can see which language will be used. For sure, language 0 is English all the time. Here is a flag which station is used. To explain, as with our twins, both stations will have exactly the same code, only there will be said if it's station 1 or station 2 to determine how the station will be seen by the code. In this way, because it's a prototype, I will do both stations on one device, so you will see that only in this prototype. I will change during the sketch from station 1 to station 2 so that both parts of the cache is running on this one device. Okay, here as ever the head times. Here is where the second station is located. Tim, you should know this because this is exactly at the small lake in your property. Here are the times, minimum and maximum times for the both routes. At the moment, I'm still, when I'm showing this, I'm in a kind of presentation mode, so you can see here. These are the times as shown on my Excel example. So this is the time when arriving at station 1, 23 hours, 11 past midnight, past what? PM. Okay, PM at least 5 minutes and 10 seconds. And this is only for a simulation. When the cacher is arriving at station 2, it's after midnight, 12 minutes and 55 minutes. So here is more or less all the stuff for working with the keypad. As you can see, these are the digits of the keypad. And then here's a lot of other stuff. A lot of serial prints are still in. This was when I'm working on it, and as ever, nothing worked pretty fine at the beginning. So I had here a lot of test printouts in serial prints. They are already now set to commit everything. And you can see here now, it's checking the status of the RTC, what I have just shown you. So two possibilities saying, okay, RTC is not working, battery is old, please call the owner, or it's showing you the time. Then you will get all the welcome screens at the beginning for the first one. And then here, if it's station 1. So if it's station 1, something here for the interrupts of the bottom are set, and then again a welcome screen is shown. Then the route is selected by the cacher. Then there is a welcome again shown after the cacher has chosen the route. Then again, if it's test mode, the time is set to the simulated time as I have just explained, otherwise it's a real one. Then we will have here the timestamp. As you can see, it's a second, the minutes multiplied with 60, and the hour multiplied with 60 multiplied with 60. As in my example, it's giving the timestamp and it's the time of station 1 in seconds. Then it's encrypted, and then there will be shown that you have to go now to station 2. So usually here the program is ending for the first station. In this simulation now comes the text saying simulation, because now it's becoming station 2. Here you can see this. Now the flag is set to station 2, and now the sketch goes on as this would be now station 2. In station 2 again, the hour will be set to the simulated ones. This is to show you this midnight examples, or later on it's the real times. So a timestamp again is calculated, some welcome screens, then you have to input the timestamp. The timestamp will be decrypted and the result will be shown, and then there is a long delay because the sketch is done now. As you can see, the loop is empty. Here is the part, I will not explain this. Here is the encryption done. Here is the decryption done. Here is the timestamp and that you shown and that you have to go to station 2. This is the routine here to select the route. Here is an interrupt for the bottom. This was a little bit nasty because this is where you have to key in station 2 the timestamp you have received, and if you can see here is checked what key is pressed, and then the string is made all the time longer. And what is most important here is if you're hitting the C, then the last digit you have keyed in is deleted. So this means if you are doing an error, you can press C and key in again. At the end, only to show you near 2000 lines, or only for the main program. So this is it, and now I will show you the prototype.